Good afternoon to one and all. I'm myself Shrikari of 9th standard. Today we are doing an experiment, chemical properties of acids and bases by using laboratory indicators. First we have to take diluted sulfuric acid. First we have to dip blue litmus paper into it. As you see, that blue litmus paper has turned into red. This is sulfuric acid which is diluted, as well as we'll dip red litmus paper into it. As you see, the red litmus paper did not turn into any color because it is an acid. This is this is the diluted solution of HCl. First, we'll dip blue litmus paper into it. As you see, the blue litmus paper has turned into red. It shows that the HCl is an acid. As well as we are going to dip red litmus paper into the HCl. The, the red litmus paper did not turn into any color, shows that it is an acid. It is nitric acid which is diluted. Now let us dip blue litmus paper into it. As you see, the blue litmus paper turned into red. It shows that it is an acid. Now we'll dip red litmus paper into it. The red litmus paper did not change its color because it is an acid. As you see here, this is the diluted solution of acetic acid. We will dip red litmus paper into the acetic acid. As you see, the red litmus paper did not change the color, shows that it is an acid. Now let us see with the blue litmus paper. As you see, the blue litmus paper had turned into red. It shows that it is an acid. This is the diluted solution of calcium hydroxide. We will dip the blue litmus paper into it. As you see, the blue litmus paper did not change its color because the calcium hydroxide is a base, and the red litmus paper had changed its color because it is a base. Now this is the diluted solution of magnesium hydroxide. The blue litmus paper did not change its color because it is a base. The red litmus paper changed its color into blue because it is a base. Thank you. We can also test the bases and acids with chemical indicators. Now I am adding to calcium hydroxide the methane orange. As you see, the solution has turned into yellow color, and we can also test it with phenolphthalein indicator. As you see, the solution has turned into pink. We can also consider it as a base. Now we are testing acetic acid. Now we are adding phenolphthalein indicator to it. As you see, the acetic acid solution did not change its color. Now we are adding methane orange to it. Now you see that the acetic acid solution has turned its color into red. Now we can consider it as a acid. Now we are testing nitric acid. Now we are adding phenolphthalein indicator to it. As you see, when we add phenolphthalein to it, it is colorless. Now we are adding methane orange indicator. As you see that the nitric acid has turned into red color, so we can consider it as an acid. Now we are testing HCl, which is diluted. Now I am adding phenolphthalein to it. As you see that its color changed into white. Now I am adding methane orange to it. As you see that HCl solution has turned into red color, so we can consider it as acid. Now we are testing sulfuric acid. Now I am adding phenolphthalein to it. As you see, it did not change its color. Now I am adding methane orange to it. As you see, the solution has turned its color into red. We can consider it as acid. If we add methane orange to acid, it turns into color red. We can consider that as acids. If we add methane orange to bases, we can consider it as bases if it turns into the color yellow. If we add phenolphthalein to acids, it shows no change of color, so that we can consider it as acids. If we add phenolphthalein to the bases, it turns into pink color, as you see here. It is a solution of magnesium hydroxide. I added this phenolphthalein. It turned into the color pink. Thank you.